Alright, so today we're solving systems using elimination. Now this is probably one of my favorite methods to solve because I didn't know about it when I was a kid, so I was very excited when I found out about it as an adult. So the point of solving systems using elimination is to get rid of a variable, hence the term elimination. So right here, what's interesting is based on mathematics, we can actually add two equations together. And it keeps things equal because one side of the equation equals the other. And if I add the same thing to both sides of an equation, the same thing to both sides, it doesn't change it. So that's the cool thing about adding equations. We're allowed to do that. So right here, I've got 2 weird circle thing plus 4 weird circle thing. So I would get 6 weird circle thing. Then I've got 3 triangles minus 3 triangles. I have no more triangles. Equals 7 minus 5 is 2. So then I could just solve for my weird little circle thing from here. So I could divide both sides by 6. And I get weird little circle thing equals 1/3. And I'm going to stop there. I'm not going to go solve for a triangle. But I could if I wanted to. Now let's try the same thing on number 2. So I've got negative 4 weird circle thing plus 4 weird circle things. So that's 0 weird circle things. And I've got 5 triangles minus 3 triangles. So that's 2 triangles. And I've got 10 plus 3. Well, that's 13. So then I would divide both sides by 2 if I wanted to solve for triangle, and I would get triangle equals 13 halves. If I wanted to from here, I could go find weird circle thing, but I don't want to. Notice that for every time, everything is all beautifully lined up. We've got circle things with circle things, triangles with triangles, equal signs with equal signs, and numbers with numbers. This is important. So let's go ahead and try that same method here. And this time we're actually going to solve for both x and y. So if you notice, we've got 2x minus 2x. Well, I can add these together. 2x minus 2x is 0, so I don't actually have to do anything with that yet. And then I've got negative 3y plus 5y. Well, that's a positive 2y. Then I have 12 plus 18. Well, that's 30. From here, I can then divide both sides by 2, and I get y equals 15. Well, that's quite beautiful because now I can use that to solve for my x. Now, it doesn't matter which equation I plug it into, so I'm just going to pick this top one because it has smaller numbers. There's really no reason why. And I'm going to take this 15 and I'm going to plug it in for the y. So that means I've got 2x minus 3 times 15 equals 12. So 2x minus 45, because 3 times 15 is 45, equals 12. And if we add 45 to both sides, we get 2x equals 57. That's a little rude. Then we would divide both sides by 2, and we end up with x equals 57 over 2, or you can find the decimal if you so desire. So that means my solution is 57 over 2 and 15. So let's try this next one. So right here, same thing. We're just going to add. So we've got 2x plus 4x, and that's 6x. 3y minus 3y, well, that goes to 0. So that I don't need to worry about anymore. Then I've got 7 plus 5 is 12. So from here, if I divide both sides by 6, I get x equals 2. That's kind of fun. All right, and I'm going to go ahead and just use my top equation here. So I've got 2x plus 3y, so this is going to be 2 times 2 plus 3y equals 7. 2 times 2 is 4, plus 3y equals 7. And then if I subtract 4 from both sides, I get 3y equals 3. And divide both sides by 3, and I get y equals 1. So my solution is 2, 1. So that's always super nice when they line up very nicely and the first terms just go away. So steps for eliminating, part A. Write the system so that the terms line up exactly. So x's with x's, y's with y's, equal sign with equal sign, number with number. Eliminate one of the variables by adding the equations together. From there you will solve for the remaining variable and then substitute the value of the variable from step 3 into the original equation and solve for the other variable. So let's go ahead and try this one out. So let's see what happens when I just add these together. So I've got negative 4x plus 4x, well that goes away. 5y plus 2y, that's 7y. And then I've got 10 plus 4, well, that's 14. From here, I only need to divide both sides by 7, and I get y equals 2, which is quite lovely, because then I just take this 2 and I plug it in for a y. I'm going to plug it in for this y. So I've got 4x plus 2, and then instead of y, I'm going to write 2 equals 4. So I have 4x plus 4 equals 4. I can subtract 4 from both sides. I get 4x equals 0. Then I divide both sides by 4, and I get x equals 0, thus making my solution 0, 2. All right, let's try this problem out. So when we add these two together, I've got negative x plus x, that goes to 0. I've got 5y plus 3y, so it's 8y. And 10 plus 2 is 12. So I divide both sides by 8, and I don't get a pretty number this time. I get y equals 3 halves, or 1.5 if you want to write it as a decimal. So from here, I'm going to take that and I'm going to plug it into one of my top equations. I'm just going to pick this one because it's got smaller numbers. So this time, I've got x plus 3 times 3 halves equals 2. Well, 3 times 3 halves is 9 halves. So from here, I would subtract 9 halves from both sides. And I get x equals negative 5 over 2. That's not too bad. All right, so then our solution in the end is negative 5 over 2, 3 over 2. Just two lovely little fractions. All right, so steps for part B are slightly different for steps for part 2. Slightly changed to step 2. So multiply one or both equations by a number that will allow you to eliminate the variable. This could be negative 1. In other words, when you add them, they don't go away, they just double. It's important to note that this does not change the equation. If you were to graph the new equation, it would be the exact same line. So here, if you notice, my y's are the same value, like exactly. So right now, if I was to add them, I would get 4x plus 2y equals 16. I didn't get rid of a letter. If I didn't get rid of a letter, I didn't do my job. So I'm going to multiply through on this bottom equation by a negative 1. So this becomes negative x minus y equals negative 3. And this top equation just remains exactly the same. 3x plus y equals 13. So now I can add them. So I've got 3x minus x, that's 2x. Y minus y, that goes to 0, it goes away. Then I've got 13 minus 3. This gives me 10. So from here, I would divide both sides by 2, and I get x equals 5. That's not too bad. So then I'm going to steal this equation right here, and instead of x, I'm going to put 5 plus y equals 3. So if I subtract 5 from both sides, I end up with y equals negative 2. So my solution is 5, negative 2 for this system. All right, let's do one more. So if you notice right here, my 5's match a number, but I need them to be opposite signs. So I'm just going to pick a random equation and multiply through by a negative 1. I'm going to pick the top one. So if I multiply 5x by negative 1, it becomes negative 5x. Positive y becomes negative y, and positive 2 becomes negative 2. Now when they add them together, I've got negative 5 plus 5 is 0. Negative 1 plus negative 3 is negative 4y. And then I've got negative 2 plus 14 is a positive 12. From here, I just need to divide both sides by negative 4. And I end up with y equals negative 3. Then I just need to pick a random equation that I like. I like this one just fine. I'm going to pick the original equation. So 5x plus, and instead of y, I put negative 3, equals, and instead of negative 2, I put the positive 2. I went back to my original equation. if I want to add, so if I say plus negative 3, that's the same thing as minus 3. So from here, I can just add 3 to both sides. And I get 5x equals 5. Divide both sides by 5, and I end up with x equals 1. So my solution would be 1 comma negative 3. All right, I want you guys to go ahead and give this one a shot. Then give this one a shot. Notice that sometimes you need to rearrange, and by sometimes I mean this one. You'll need to rearrange it so that x's line up with x's, y's line up with y's, equal signs line up with equal signs, and numbers line up with numbers. Okay, and then this one will be your final question. Again, you'll need to rearrange this equation so things line up, and you'll need to rearrange this equation so things line up. Okay, then once you're done, go ahead and write your recap, and you are done for today.